Hello out there, welcome to this tutorial on vectors. In this video, we'll be looking at component of vectors in two dimensions. First, we look at the representation of components of vectors in two dimensions. From the Cartesian plane below, we have the x-axis, the y-axis, where O is the origin. We consider a unit vector I along x-axis and a unit vector j along y-axis. So we have said that where I and j are unit vectors along x and y-axis respectively, and the coordinates of I is 1, 0, and that of j is 0, 1. So we now consider a vector r. This vector r starts from the origin, and we look at the endpoint here. That is, if we take it as x and take this one as y, the vector r is represented in component form as r equal to xi plus yj. So this is xi plus yj. This is the I component and this is the j component, where these x and y are scalars. For information, r can also be written as r equal to x, y in column form. The vector x, y is called a column vector. This is the representation of components of vectors in two dimensions, either in component form or as column vector. So that is all for representation of components of vectors in two dimensions. So we then go to magnitude of a vector in terms of its components. So the magnitude of a vector r equal to xi plus yj is also known as modulus of the vector, and it's given as modulus of r equal to square root of x squared plus y squared. So from here, the modulus of r, which is also known as the magnitude of the vector, is the square root of the sum of the squares of the ith component and the j component. So we now look at problems. Find the magnitude of each of the following vectors. We have r1, r2, and r3. So in our solution, we start with r1. So r1 is equal to 4i plus 3j, so that the magnitude of r1 now is square root of 4 squared plus 3 squared. 4 squared is 16 plus 9, giving us 25. We have it as root 25, and root 25 is equal to 5. And that's all for magnitude of r1. For r2, we have r2 equals negative 2i plus 5j, and then the magnitude or the modulus of r2 is going to be square root of negative 2 squared plus 5 squared, and negative 2 squared is 4 plus 25 gives root 29. And that's all for the modulus or magnitude of r2. For r3, we have it as negative I minus 7j. So the modulus of r3 is going to give us square root of negative 1 squared plus negative 7 squared. We can equally call it the coefficient of I. So that is going to give us negative 1, which is squared. And here the coefficient of j is negative 7, which is squared. And this is 49 plus 1, giving us root 50. And root 50 is simplified as 5 root 2. And that's all for the magnitude of a vector in terms of its components. And this is the highest we can take in this tutorial. I hope you enjoyed this video. Please like and share this video, and remember to subscribe to our YouTube channel. Goodbye.